All right, let's review the key vocabulary of a unit on logic reasoning to get ready for our unit test. We talked about two different types of reasoning: inductive reasoning and deductive reasoning. Inductive reasoning uses observations to find patterns. And from that, take a guess on what's going to happen next. Deductive reasoning uses facts, definitions, properties, theorems, and postulates. And it puts those together using laws of logic. If you use inductive reasoning, then you come up with a conjecture. The conjecture is a guess based on our observations, and it's a guess that is unproven. A counterexample is a specific case that proves the conjecture false. See, that's the thing about conjectures. We can find many examples for which the conjecture is true, but if we found just one example, one counterexample for which the conjecture is false, then we can just do away with our conjecture. Negation. Negation means we put in not or take out not from a statement. An example would be, I do not like to run, which is negated by taking out the not and saying, I like to run. Now let's talk about our conditional statement. A conditional statement is usually written in if-then form. Let's use an example. If he runs, then he sweats. If he runs, then he sweats. Remember, we can use symbolic notation to shorten things up. So if I use R for the statement he runs and S for the statement he sweats, then in symbolic notation I will write if R then S. And remember, our statements, he runs, in this case, is the hypothesis. The statement he sweats is the conclusion. And the if and the then are never part of those statements. No matter in which order they come, if and then are never part of hypothesis or conclusion, because we can change those around. As we will right now. Look at the converse. The converse flips the conditional. Flips, you can also think moves, and think about our Converse sneakers that help you move around. So then if we move or flip the hypothesis and the conclusion, in symbolic notation we would now write if S then R. In other words, if he sweats, then he ran. And don't worry about using a different tense here. We just have to see how it makes sense. The inverse negates the conditional. And it negates both parts of the conditional, the hypothesis, as well as the conclusion. In other words, using a squiggly line for symbolic notation, if not R, then not S. And our example would be, if he does not run, then he does not sweat. Remember, R is the statement he runs, S is the statement he sweats, and the not was indicated by our squiggly line. Now the contrapositive does the whole shebang, right? It flips and negates the conditional. It does everything that we can think of to a conditional statement. And really, you need to remember, we are basing everything off the conditional statement. The contrapositive flips and negates the conditional, not the converse or the inverse. Going back to the conditional, therefore, in symbolic notation, we will say, if not S, then not R. And our example, therefore, states, if he does not sweat, he did not run. A biconditional statement. A biconditional statement is a statement that can go both ways. And what's special about a biconditional statement is that since it can go both ways, both the converse and the conditional are true. In symbolic notation, and I'm going to use two different letters now, we would write T if and only if U. Remember that arrow that goes both directions stands for if and only if. An example of this would be a polygon is a triangle if and only if it has 3 sides. And remember, the if and only if we can also abbreviate by writing IFF. Then let's take a look at our symbolic notations and the symbols that we have already used and are using. The arrow in one direction stands for then. Then we have the arrow that goes in both directions, which stands for if and only if. Abbreviated by IFF. Our three dots in a triangle shape stand for therefore, which introduces our conclusion. The symbol that looks like a capital A but isn't finished, it's missing the middle bar, stands for and that symbol flipped on its head, which looks like a V, stands for or. Venn diagrams represent set relationships. In other words, the relationships between different sets that are part of a universal set. Some helpful hints about what Venn diagrams look in terms of certain words that we use for our statements. A statement that has the word all will be represented by a Venn diagram which has a larger circle and a smaller one that's fully inside. The statement some, which might also have the word might in it. Some will be shown as two circles that have part that overlaps. In other words, for example, you could say some people like dogs, some people like cats, and some people like both dogs and cats. None or not would be represented by two circles that are totally apart from each other and have no overlap. A set is shown in a Venn diagram, and that is really a collection of objects or groups or names, numbers, whatever it is that you are analyzing. Then let's talk about our laws of logic, the laws that we use when we perform deductive reasoning. The law of detachment uses one fact only. Remember, detachment means, or detached means something is removed, is apart from something else, or from everything else really, and it uses only one fact. The way it's structured is usually if P, then Q. P is true, therefore Q is true. Let's find an example. If he runs, then he sweats. He ran, therefore he sweated. The law of syllogism, on the other hand, uses many facts and links them together as a chain. If P, then Q. If R, if Q, then R. We need to, of course, continue with the element that was the second element in the statement before. And we could keep going, but for easily's sake, just finish it here. Therefore, and we can now go ahead and get rid of our Q, which is our link that links the two statements together, and get to our conclusion. Therefore, if P, then R. If he runs, then he sweats. If he sweats, then he showers, which is a good idea, by the way, right? Therefore, if he runs, then he showers. Well done. Okay, let's talk about the law of the contrapositive, but that also is very closely linked to equivalent statements. Equivalent statements are statements that have the same truth value. And of our 4 statements that we discussed, our 4 different forms of a statement, we have 2 pairs that always have the same truth value. The converse and the inverse. Have the same truth value. And so do the conditional and the contrapositive. And that's essentially, the last bit here is essentially exactly what the law of the contrapositive says. The conditional and the contrapositive have the same truth value. Let's look at an example. If P, then Q. Therefore, if not Q, then not P. If he runs, then he sweats. Therefore, if he doesn't sweat, he didn't run. And there you go. That's your logic reasoning in a nutshell. Have fun studying, and I will see you in class.